Hello, here's an example of a binomial probability distribution problem. In this problem, we have 38% of women consider themselves fans of professional baseball. You random select 6 women and ask each if she considers herself a fan of professional baseball. Looks like they're surveying 6 women. The probability of success is 0.38. And here, this one will be easy to use Minitab. Let me show you how to do that. In Minitab, I already plugged these values. I just typed in X and I typed in numbers 0, 1, 2, 3, 4, 5, 6 just to show you something. You could just type them in. There's another function that allows you to do this. So because you might have more than 6. If you go to Calc, make pattern data, and then simple set of numbers, I can go store pattern data in X. My first value is 0, and on my last value is 6, and it's just going to count by ones. If I click OK, it'll place those numbers there for me. Or you could have just typed them in, either way. Then I'm going to go back to Calc. I'm going to go probability distributions, binomial, and then here I'm going to type in, this one's 0.38. Number of trials is 6. 0.38 was the percentage of probability of success. And here, that's from the last problem, just to show you. All you do is put your cursor in input column, and then this should pop up. Put your cursor here for optional storage. This is where it's going to place the values. Going to do P of X. Okay. There are your solutions. Here, let's go back just to show you. Here, same values here. The next one says choose the correct histogram for the distribution below. To get this particular one, you can graph it. Let's go to graph, view probability distribution plot. Let's go view single. I think you can do it with this one. I'm going to go to binomial, and number of trials in this case was, I believe it was 6, and I believe it was 0.38, 38%. Then click OK. And there's a picture of my graph. Let's see if I can match it up. Well, I guess we have the answer here, but you would just match it, the one that looks closest to your graph. And this one is somewhat skewed right. Something to note, this one's kind of hard to tell. You can kind of tell, but it's kind of hard to tell. Just know if your P was 0.5, your probability of success, this is 0.5, this graph would be exactly symmetric, which means you couldn't, it's exact. If it's less than 0.5, it's skewed. It's probably really skewed right, but one way to tell is just pick a p-value that's really small in your graph. We're just testing. So I'm going to go here, here, and click OK. So instead of 0.38, since it's less than 0.5, I know it's going to be the same skewness. So I'm going to make it 0.1, just so I can see a graph that's really skewed, so it's obvious. Okay, now this one's very obvious that it's skewed with the tail to the right. So then I know on my solution that it should be skewed right. Next one, find the mean. That's just a formula. And the formula for find the mean is n times p. N times p, my n is 6. My p is 0.38, so it's just 6 times 0.38. And then your variance is n times p times q. Your n times p, that's the same thing. Your q is always 1 minus p. So in this case, my q is 1 minus 0.38, which is 0.62. So I'd multiply 6 times 0.38 times 0.62, and that would give me your variance. Your standard deviation is always the square root of the variance. So you'd find the square root of this variance, and that'll give you the standard deviation. And down here, you're kind of just answering the question. It says, on average, that's the mean. Out of 6 women, will consider themselves baseball fans with a standard deviation of here that we already calculated. The values of 5 and 6 would be unusual, and that's because the values of 5 and 6 have a probability that's less than 0.05, and they're defining that as unusual, less than 0.05. And I believe that's it for that one. If anybody has any questions, always let me know. Thanks.